Imagine this, a world where the concept of distance is erased. A future where you could step into a chamber in your hometown and, in an instant, find yourself halfway across the globe. No flights, no long drives, no waiting, just the seamless, effortless ability to be anywhere, anytime. It's a vision that has captivated humanity for centuries, a dream once confined to myth and science fiction. But now, science is on the brink of turning this dream into reality. Teleportation, the idea of instantaneous travel, no longer belongs solely to the realm of fantasy. Over decades, scientists have chipped away at the barriers that once seemed insurmountable. At the heart of this revolution lies quantum entanglement, a phenomenon so strange and so profound that even Einstein referred to it as spooky action at a distance. Particles, no matter how far apart, seem to share a connection, reacting to each other instantaneously. And if particles can do it, why not humans? The journey to harness this mysterious phenomenon has been one of discovery and ambition. First came the teleportation of particles, then molecules, and now living organisms. The leap from science fiction to reality has never felt closer. But as with all great discoveries, the road ahead is far from straightforward, and the risks may be greater than anyone imagined. The first successful teleportation of a living organism was met with global excitement. Every atom, every molecule was accounted for, perfectly reconstructed at the other end. The implications were staggering. What if this technology could revolutionize human life? No more traffic, no more physical barriers. A connected world, instantaneously accessible. But as the celebration subsided, questions began to surface. What happens to the original? Teleportation, as it turns out, doesn't move matter in the traditional sense. Instead, it scans, disassembles, and recreates. The person who steps in the chamber is effectively destroyed, and an identical copy is created elsewhere. To the outside world, the process is seamless. But to the individual, that raises a chilling question. What if the person who steps out isn't truly you? As teleportation spread, reports of anomalies began to emerge. Some users described a vague sense of unease, as if they were out of sync with the world around them. Others spoke of fragmented memories, visions of places they'd never been, events they couldn't have experienced. And then there were the failures. Travelers who didn't reappear, or worse, those who did, but not in the way they had left. The deeper researchers delved into the technology, the stranger the discoveries became. During teleportation trials, strange phenomena were recorded. Brief, fleeting presences that defied explanation. Some dismissed them as glitches in the equipment. Others began to suspect a darker truth, that teleportation wasn't just transporting matter, but opening a doorway to something else. If teleportation truly creates rips in the fabric of reality, what might it be exposing us to? And what might be stepping through those rips? The anomalies were too consistent to ignore. Shadowy figures observed during the process. Changes in the behavior of travelers. Unexplainable disruptions in the quantum fields. What if, in our quest to conquer distance, we've drawn the attention of something out there? These discoveries have sparked debates among scientists, philosophers, and ethicists. The promise of teleportation is undeniable. A future where humanity transcends physical barriers and moves freely through the world. But the risks loom large. Are we prepared to embrace a technology that challenges the very nature of identity, reality, and existence? What if, in achieving the impossible, we unleash forces we can't control or even comprehend? Teleportation represents humanity's boldest step into the unknown. But as history has shown, progress often comes at a price. The question is no longer just whether we can teleport, but whether we should.